And I am aware that you will probably know most, if not all of them already. Okay, so here we go. So we've got, when it comes to types of angles, right? We have acute, right? It would look something like that. Less than 90 degrees. Obtuse, right? It obviously is greater than 90. Right angle, no news there, right? That's exactly 90, and we use a little square to denote that. Straight angle is like, there's usually a point of intersection. If you look at all of these, there's a point where two lines meet, right? Meets, and then if you have two lines that meet and are exactly horizontal, that angle formed by those two lines is 180 degrees, right? So that's by definition what a straight angle would be. And a reflex, if you look at this angle here, instead of, like, they meet right there, instead of focusing on this part, we would focus on the outside right here, and it's greater than 180 degrees. That's what a reflex angle is. So there are your angles. And I'm going to introduce to you properties, guys, of angles, but these ones are always true. Okay, so these ones you can always use, but the ones I'm about to introduce you to, not always true. Okay, so properties that are always true, but very big, cannot be used to justify whether or not lines are parallel. I don't know, green doesn't do a good job, does it? Might have to go orange. But they cannot, you can't use these and say, hey, lines are parallel for this reason. But when you just look at and you want to find missing angles, right? Complementary angles, angles whose sum is 90, and a way to remember is it's right to complement someone, right? It's the right thing to do to complement someone, so that reminds you that it's a 90. And so if this is 20, if you wanted to, and you know that these sides out here make a 90, then obviously angle Y would simply be 90 minus 20. So angle Y is 70. No surprises there, but sometimes students miss it. They miss the fact that, hey, there's an easy way to find Y, and there it is. If you, in this particular example, right, supplementary angles whose sum is 180, right? And so let's say you know that this is 30 degrees here, okay? And you wanted to know what angle X is in here, right? Angle X would simply be 180 minus the 30. Angle X is 150. No news there. The shortcut for, like, if you ever use that, right? I'll say that the shortcut, I'll put it right here. This is the explanation. Straight angle is equal to 180. You don't need to actually write out the property. You can just use this one. That would be a justification explanation, right? And it doesn't have to be just two angles. It can also be, right, in this case, you have three angles along this horizontal line there. You can use think, right? So this here indicates, right, it's a straight angle. And we know that that's equal to 180. right? So the angles that are along this straight angle, their sum needs to be 180, right? So to find angle X, we would simply go 180 minus 31 minus 24. And so angle X ends up being 125 degrees. I don't know if I want to take this to another level entirely, but it'll come your way. It just gets, if you don't want to copy this, that's fine, but it will get, you will see a lot of lines, right, like this. And that's when it gets, perhaps you don't see the straight angle, but it is there. It is there. If you just focus on any line here, any straight line, let's say you want to focus on this one, right? If you were to focus on that line, you do have three angles, right? X, Y, and Z, right? These three angles along this straight angle would be considered supplementary, right? Angle X plus angle Y plus angle Z, it would be equal to 180 in this case. So there's straight angle. So it is useful in a lot of applications. You just have to recognize it. So remember, I will say this a lot, everything is connected that we do. You'll see some connections from this chapter in trigonometry. You will see things are always connected, right, in math. So it's not like it's just true here, it's always true. So try to apply your knowledge to everything else. All right, let's keep going. I revamped this booklet, so it might be a little different than, the order might be different than mine, so I just have to watch out here. Page 3, it says that vertically opposite angles are congruent. Okay, equal. Congruent is equal. Okay, so the symbol for congruency is an equal sign followed by a third wave. That used to be funny during COVID time, right? Second wave, third wave, right? Anyways, so we had, that's a symbol we use for congruency. And the shortcut, you can use this, vertically opposite angles are congruent. Like if I ever ask you to justify, how did you get that angle? That's the shortcut right there. It saves you a lot of space and time, right? So vertically opposite angles, that is the angle symbol right there. And by the way, if you deviate from it a little bit, like if you forget the S there, not a big deal. Okay, like I just want you to have a quick way of referring to it. So if you have, I'm going to use a red pen for this part. If you have a blue pen, it's fine. Just sticks out more if it's a color, right? So if two lines meet, there could be three lines, by the way, or more. But if we just focus in on that point right there, and let's say this angle right here, I just got this pen there. If this is angle X, vertically opposite to it would be right here. Okay. And we would say that angle X is going to be exactly equal to angle Y. And the justification would be vertically opposite angles, right, are congruent. Because if you think about it, if you were to be able to fold it right here, fold that side over to this side, it'd be exact copy of the previous angle, which is very helpful. Okay, so for example here, if you just focus in on that one, and this is where highlighters come in handy, right? If you just focus in on this angle right here, that one, if you just follow those two lines that created it, would be vertically opposite to this one here. Okay. So we would say, and I will usually give you a little bit of a chart to fill in, you would say angle Y is equal to 29 degrees. And why would that be? Because vertically opposite angles are congruent. That's your justification explanation. Right. Now, do you see another pair of vertically opposite? Yeah. Which one would it be? X and 35, right? Okay. So whatever color you have, right, for now. And I'm going baby steps here, guys. Okay, so if it's a little bit slow for you, just hang in there. It's gonna change. So the shortcut beats you having to write out vertically opposite angles are congruent, right? So I'm here trying to make your life a little bit easier. How would we find Z? We just talked about it. Luca. 180. All right, so 180 shows up quite often. And he's talking about straight angles, right? So I'm gonna just highlight this one here. Right, Luca might have done a different one, but I identified this straight line here, and I know that all three angles along that pink line add up to 180, right? So in this case, I could easily find that one. So angle Z is 180 minus, I already have Y, right? This is 29. You can write it in here. Minus 29 minus 35. Angle Z is, I'm just going to look at my key here, don't want to get it wrong, is 116. So this is showing a little bit of work because sometimes you can't just see it right off the bat. You have to do a little bit of work and then we'll just go straight angles equal 180. Right? So I'm kind of giving you a little bit of a heads up what's coming. So I don't just want the number, I also want some kind of justification as to how you got that. And so we use the combination now vertically opposite and straight angles to get that, okay? The sum of interior angles of a triangle is always equal to sum of interior angles of a triangle, always add up to 180. You remember that, right? It doesn't matter what it looks like, it's always 180. 180 degrees. And the shortcut is, what did I, oh yeah, here. Sum of triangles equal to 180. That's the explanation, justification for that one, if you use that one. Sum of interior angles of a quadrilateral. Triangle is 3 sides, right? Quadrilateral is 4 sides, and it's equal to 360. Think of a square, right? 4 angles measuring 90. That's 360. So we'll say this one, sum of a 4-sided is equal to 360. Feel like I need to give you this example here. So just, I know my artistic skills are less than ideal, but let's try this. Maybe watch me copy it first. right? That would be a four-sided shape right there. And if you had 80 degrees, 55 degrees, I will make this 140 degrees. And let's say this angle here is B. And I know you're probably used to angles have to be capital letters. Sometimes we do use capital letters. Sometimes when they're inside the shape, we use lowercase. So it's okay, right? So to find B, right, angle B, we would simply take the fact, right? Like it's a four-sided shape, four sides. So I know they add up to 360. So we'll just start subtracting angles we already know. So 360 minus the three angles you are given, that adds up to 85 degrees. And how did you get that? Well, I used this property right here, which is always true. I'm not going to do a triangle one because I think you know that one already. You've done triangles before. Just for time's sake, we're just going to skip that one. Three-letter notation. You need to know this one. The test will most likely have at least one question, if not more, that use the three-letter angle notation. Okay. So, for example, if you want to refer to this angle right here, I'm going to use a highlighter for that. So let's say you wanted to refer to this angle right here. You can't just use D, right? Because D has two angles, right? You could mean this one or that one. So if you want to refer to that angle right there, okay, you would have to use a three-letter notation. And it doesn't matter if you go clockwise or counterclockwise, but I kind of tell my students, yes, it's D, right? So it's D. What's to the right of it? There's a B there, right? And left of it, you have A. So this angle is called ADB, right? So if you connected the 3 points, that angle formed between them is what we're after. You can also call it BDA if you want, BDA or BDA, but notice that D is always in the middle. And so if you wanted this angle right here, okay, that angle right there, D is in the middle as well. So let's start from top here. So I would have B, right, BDC, or you can just start with the other, kind of read it backwards. CDB, it's the same thing. We're talking about the same angle. But I'm going to be gracious to you, okay? If you want to on a test, right? So I'm like, hey, find angle CDB, and you go find, okay, CDB, okay, it's this one right here. You can put a lowercase letter in there. You can go A, B, C, X, Y, Z, whatever you want. And then you tell yourself, okay, that's angle X. So how about we do that? We'll call this angle Y. So I'll put Y in here. And these two here, for us today, that's angle X. So you put an X in there. And now it's easier to say, hey, okay, we're talking about that angle right there. And then you're not struggling with the three-letter notation. And I have another one here. And I'm going to ask you to find it real quick here. What's the value of GKC. I want the actual value. The angle B. Can you see that? Yeah? Okay. Okay, I want you to give me the angle measure of those. Those are easier ones. Then I will also ask you for those. There. Read it exactly the way I give it to you, right? GKC. So you go GKC, right? So it's actually asking for this one right here. And that one actually, look at they're right next to each other along a straight angle, right? So you can actually just find this, right? You just say, hey, that one is going to be 180 minus 97, right? And that's 83 degrees. So this is supposed to be 83. Okay, next one, BAE, right? So BAE is this one formed right there. It's actually this one, which is also 83. Use a different highlighter if you need to. Okay. Couple seconds again, those of you that were stuck. We're good. I don't have as many highlighters as I have angles, so I won't be able to do them all. It's frozen. LFD. LFD is right here. That's 103. KHF. KHF, where are you? KHF, right? So KHF, it's this angle right there. That's 77. AFH. So these one are a little bit more, well, not really that challenging, but AFH is right here. AFH. So it's actually asking for this angle right there. That's the angle, but do we know what it is? What is it? 103, right? What property did we use there? The shortcut. Vertically opposite, right? Vertically opposite. Okay. So this is 103. So it's 103. Vertically opposite angles are congruent. Okay. AKH. AKH. So it's this one right here. I'm almost out of ammo here. Let me see. This one is somewhat different. AKH. This one right here. And that one is, yeah, if this is 83, then this is 83 also, vertically opposite. Like these are exactly the same. Why is he doing that? Why is he always justifying? Trust me, you're going to need to do that later on, so get used to it. CAF. KAF, it's this one right here. That's also 83, right? No highlighter for that one, sorry. Enough is enough. So These ones definitely needed a little bit more work to them, but remember, everything is still true. What do you think all four of these angles should add up to? 360. Could you have used that property to find this angle? Should it have been the same as 83? It better be, or else all our findings in math are wrong, right? It should be. If I did this right, if I draw to scale, yes. Okay. And I am drawing most of them to scale using an awesome app. Okay. So keep going. I hope you will not have nightmares when I give you 3-letter notation questions. And quite often I don't, because I don't want to focus too much on that, but you need to be prepared for it. So this one, watch this, guys. There's a bunch of missing angles. And obviously you need to find the actual value here in degrees, right? And this would be the justification where you would use vertically opposite, sum of triangle, all those right here. And I know I might throw you in a little bit too soon for this, but I will actually make this your homework, part of your homework. Okay, so I'm not going to do it today. I will ask you to try to use what you already know to find the missing angles there. So you can use straight angles, you can use vertically opposite, you can use sum of, is this a four-sided shape in here? Oh yeah, it is, right? You can use that one. So you use your tools that you've learned so far. So let's keep going here. Parallel at transversal lines. This is a very important concept here. Should have made the title a little bit bigger. Parallel lines, what are they? Two or more lines that are parallel if they never meet or intersect. So parallel lines never meet or intersect. That's by definition what parallel lines are. They run alongside each other. And remember, when the slope is the same, an IPR, remember, slope is the same, never meet, no solution to the system, right? Don't worry, we're not doing that here, but it's the same idea. You can recognize parallel lines when the symbol in the form of arrowheads is visible on two or more lines. So watch this. These two lines here, these two lines would be considered parallel, and these two lines would be considered parallel. Okay, so you have a combination of parallel lines here in this particular example. So I would say AB is considered parallel. So AB is parallel to CD, right? This would be AB is parallel to CD, obviously. Also, GH, right? EF, segment EF is parallel to GH. So you've got two sets of parallel lines there. And the shape that is formed in here is actually a parallelogram. Okay, in this case, because you've got parallel sides here. This is a parallelogram. Yikes. Ran out of runway there. Transversal. So parallel lines, that's a definition, and that's how we indicate it on a diagram, right? Sometimes it's just in words, and sometimes it's just with the markings. Okay. Transversal, a line that intersects, right? A line that intersects two or more lines. Okay. A line that intersects two or more lines is called a transversal. But I have to tell you that a transversal can also be parallel to another line. Okay. When a line is referred to as a transversal, we know that along it, we have four distinct parallel pairs of angles. So in this case, this example only has one transversal that cuts, in this case, three different lines. So that one is called a transversal. And we're going to be zooming in. Along that transversal, there's angles formed by the transversal and the lines it cuts. And those we have names for. Okay. Just keep in mind that let's just go up here for 1 second. In this particular case, if we get rid of, just forget about that one, this would be a transversal as well in this case. But it happens to be that this transversal has a parallel line as well right across from it, right? So here you have two transversals going this way. But if you want to focus from this side, there's also two transversals because each one of these is cutting two or more lines at distinct points. So keep that in mind. Keep going. There was a time where all my students had to first graph all of these things and then we would copy, right? So it's kind of nice that it's no longer the case. These are the four distinct angle pairs found along the transversal. These are the ones we're going to be kind of focusing on quite a bit. So corresponding angles, I'll just call them CAs. Okay? Just for short, because later on we'll use that to justify things. So if this is your transversal here, okay, corresponding angles say this. This is the definition. You ready? They are found on the same side of transversal. I'm giving you a summarized version of this. Same side of the transversal, comma, one interior and one exterior. This is a very summarized version of what I'm about to show you. Okay. So what is interior, exterior? What is all that about? I call the two lines here, it's kind of like a sandwich. So I would call everything inside the bread, right, would be interior. Therefore, everything outside would be referred to as exterior. So everything below this line right here is all exterior. That's all exterior up here. Interior is this side, is what's between the two loaves of bread. Okay. Okay, so I will highlight. So if you have a highlighter, if you focus on the transversal, when you want corresponding angles, they're on the same side of the transversal, one inside, one outside. So in this particular case, 1 and 5. One is outside, one is inside. Those would be considered corresponding angles. So let's write it down here. 4 pairs in this case. 4 pairs. 1 and 5, angle 1 and angle 5. I'm writing it down right here. Angle 1 and 5. Use a different highlighter if you have one. 4 would be corresponding to 8. Okay. So there's on the same side of the transversal, one has to be interior, one has to be exterior. So we'll put angle 4 and 8 Let me move this up a bit. And I think I'm going to leave it at that. But now if you go to the other side of the transversal, 2 would be corresponding to 6, right? 2 and 6. So angle 2 and angle 6, as well as angle 3 would be corresponding to 7. Okay, 3 and 7. And why not do this, right? This is my first pair, and this is my second pair. Like 4 and 5 are not corresponding because they're both on the inside. Doesn't work. Can I say this? Some students would argue, well, what about 5 and 8, Mr. Dirksen, because one is inside, one is outside? No, they cannot be touching, right? They cannot be touching. They're not adjacent. So kind of just remember the pattern: 1, 5, 4, 8, right? 2, 6, 3, 7. Okay, let's keep going. Alternate interior. Those ones I call AIs or AI. Alternate interior angles, okay? And I want you to focus in on that word alternate right here. Alternate, that word indicates opposite sides of transversal. That's what that word alternate means. Remember, we're right now focusing on, you find your transversal, which is in this case this line right here. I only have one. And so the word says alternate interior. Alternate interior. And so interior means that both of them have to be on the inside. So if you have a highlighter, 4 is alternate interior to 6. And 5 is alternate exterior to 3. They kind of make an X if you see that, right? 2 pairs. Angle 4 and angle 6, as well as angle 3 and angle 5. So you only have 2 pairs of those. I'm going to match my colors like that. And let's add the word interior here, right? And by tomorrow, you should have something on your study sheet that allows you to determine them quite easily. Okay. Some students just make this, copy this, and then they just write corresponding. They just have one example of corresponding, one example of alternate interior, and so forth, and then they just know how, like, the rest of the pattern. Okay. Let's keep going here to something that looks very similar. See this word? Still means the same thing, right? Opposite of transversal. This says opposite side of transversal still, but in this case we focus on exterior. So this would be exterior, this would be exterior. So you know both have to be exterior. And so if you, for example, want to go with one, if you start with 1, the alternate exterior to it would be you're making an X, so you go over to 7 out here. And if you, let's say you start with 8 here, that's where you start, then the alternate exterior to it would be way out here. And you have, just like before, 2 pairs. Angle 1 and angle 7, angle 2 and angle 8. And I will match the colors. 2 and 8, I use green for that. 1 and 7 are and consecutive interior. Oh, let's call this the shortcut alternate exterior, right? AE, if you don't want to use the whole thing, I'm okay with that. So CA, AI, AE, and this last one says consecutive interior, right? Another word for this is adjacent. No, sorry. Can we undo that? Don't worry about it. I got this wrong. I was thinking of something else. Consecutive interior. I will just say this. Same side of transversal. That's first bullet. Both interior. So again, let's focus on the interior. And so consecutive interior here would be 4 would be consecutive interior to 5. And 3 would be consecutive interior to 6. So there's no crossing there on the same side of the transversal, both interior, so 2 pairs. Angle 4 and angle 5, angle 3 and angle 6. And there's that one. And I use green for 3 and 6. And this is the name for it. I'm gonna go CIA, okay? I don't know, it just sounds better. CIA, consecutive interior angles. And look at what it says at the bottom of this. These 4 angle pairs are always found along the transversal. Okay. If you follow the transversal, you will always find these 4 types of angles along the transversal. So, right, if you focus on this one, there's alternate exteriors, we have alternate interiors, we have corresponding, and we have consecutive interiors. So all 4 of these types are found there. So these are important for you to know, okay? Now that we know them, we have a name for them, right? We're gonna look at the following conjecture. This is on page 6. Let me see here because I changed this up a little bit. watch this, guys. On page 6, okay? So this is saying that it goes both ways, okay? So watch this. When a transversal line, right? When a transversal intersects lines that are parallel, okay? If you have, when the transversal intersects lines that are parallel, then all of the following are true, okay? Alternate exterior angles are congruent. Alternate interior angles are congruent. Corresponding angles are congruent. Consecutive interior angles are congruent. Oh, wait. Supplementary. So, very important, very important, very important. I will summarize that. Just give me a second, okay? So this is true. So let's use notations. So if transversal cuts parallel lines, okay, this is just plain English here. If transversal cuts parallel lines, right, then all of these are true. You have that alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. And the CIA's angles are equal to 180. That's what that box up there is saying. So on the one hand, if the transversal does cut parallel lines, then all of these are true. Okay. On the other hand, watch this. Let's say we don't know if lines are parallel. Okay. All we need to do is show that one of the following would be true. Okay. You can either show that alternate exterior angles are congruent, alternate interior angles are congruent, corresponding angles are congruent, or consecutive interior angles are supplementary. Then you can actually conclude that the lines that have been cut are parallel. Okay. So basically, are lines parallel? That's the question that you will be posed. Okay. Show one of the following. Okay. That alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent, or that the CIAs are equal to 180. If yes, right, if yes to any of the above, comma, we say lines are parallel. So this is coming at it from a different perspective. The question is asking you, are lines parallel? Then we'll show that one of these is true. You're like, Mr. Erickson, why not all of them? Why not all of them? It just so happens that if you can just show that one of them is true, you will find out that they are all actually true. Okay? Okay, so here we go. This one has actually been sketched. I drew this to scale. Okay, let's zoom in. If this is a transversal here, let's say this is transversal 1, and this would be transversal 2. Okay, T1, T2. Can you see that if we look at corresponding angles? So corresponding, I will use orange for it. Oops, sorry, you can't see that, can you? Sorry, guys. Let's just find the corresponding angles along this line here. I'm focusing on a transversal here. Let's say you're looking at 118. Which is the corresponding angle to 118? It would be this one here, right? You see that they're equal, right? So you can say that, hey, I just found out that they're congruent. And it will end up being the case that, let's look at alternate exterior. This one is 1, and the alternate exterior to that one is this, right? You actually see that alternate exterior angles are congruent also. You're like, Mr. Erickson, what about all the other ones? Don't you want to? No, you just have to focus on one pair. Okay. Let's look at alternate interior. Got to use even more highlighters. I'm going to say that, see that these are alternate interior, right? They're both congruent. Mr. Erickson, why are you changing your notation? I don't know, just because I want to let you know that I don't really care how you do it as long as you know what you're talking about. And what's the fourth one? Fourth one is consecutive interior, and I don't want to use a highlighter because it's going to kind of butcher stuff. But these two here are CIAs. So are these two. Do they add up to 180? They do, right? If you add that up, they actually add up to 180 degrees. So we can say that the CIAs are equal to 180 degrees. So wait a minute. If these are all true, we can actually do this. Grab your pencil and say, hey, this line, because if I focus on this transversal that cuts two lines, if all of these four are true, I can actually put the symbols down and saying, hey, these are actually parallel. These are parallel. Okay. And you know what the beauty is? You actually, if you're asked to see if they are parallel, just choose one of these, right? You could have said, corresponding angles are congruent, done, right? You drop the mic, you walk away. Right? I'm just going to focus on the alternate exterior. Okay, drop the mic. You can say they're parallel. We're done, right? Consecutive interior, like you want to focus on these two and just add them up and hey, they're 180. We're done here. Because when you find one, all of the other ones will end up being true as well. So you're like, okay, Mr. Dixon, what if I chose this transversal here, cutting these two lines? Well, let's see. My alternate exterior are, can I call this one alternate exterior to this one? Right? They're congruent. That's good. We're good there. Corresponding. Let's pick a pair of corresponding. I'm going to go 100 and 100. These two are corresponding. And I'm using the color code that I've used here, by the way. Alternate interior. I'm not going to use 100 and 100 because I already kind of used it. So 80. This is alternate interior to that one. And this one is very easy to decide, right? CIAs would be equal to 180. So it doesn't matter which transversal you use. Guys, once lines are parallel, I could keep cutting this every which way with 1,000 transversals. The fact that they're parallel will not change. So your approach to it will change. How you justify will be different than me sometimes, but that's okay. Do you notice that vertically opposite angles are congruent as well? Do you notice that if this adds up to 180 and this adds up to 180 as well, you see the four-sided shape in there, the quadrilateral, 180 and 180, 360. You see that? Is it possible that a triangle will show up every once in a while? Yes, it will. You bet. You're following? I know it's a lot. I'm kind of dumping a lot on you, but watch this. Now it gets crazy. Ready? If I wanted to do this, just follow me here. I will not highlight anything. If I asked you, hey, is this line parallel to this line? No, because I can see it, right? You can see it. But what if it had been off by just 1 degree? You would not see it, right? How can you do it else in a different way? If you focus as this as your transversal, right? What would these two angles be? Alternate exterior, right? Yeah, I know you're thinking it. Are they congruent? Nope, fail immediately. They're not parallel, right? So it goes both ways. If yes, as soon as one of them is not being met, everything else will crumble. For example, right, 80 and 62 does not add up to 180. These are consecutive interior. Alternate interior angles are not congruent either. So it's kind of like a ripple effect, as you can tell. Okay, I feel like I want to do a little bit more, and then I'll leave you alone. I have 10 minutes, but I'll try to do it in 5, and then you'll have 5 minutes to decompress and just kind of figure out what hit you, right? Let's go to 7. Let me think a little bit. Hold on. Yes. Okay. I'm giving you some steps here, proving if lines are parallel. Like if a question asks you for that, I'm going to box this in. How would you do that, proving that lines are parallel? You can't just look at the lines and say yes or no, just like earlier was very obvious, right? Try to find an angle pair with a name, right? Name, one of the 4, right? Alternate interior, exterior, corresponding, or CIA. You might have to resort to, right, what you already know. This is always true. You might have to use the sum of triangle, supplementary angles, vertically opposite. Straight angle is not there, right? Straight angle is equal to 180. Sum of this is 360. You know, these are always true. You can use them to build your case, to figure out missing values. Then check to see if the property about them is true. If yes, lines are parallel. If no, lines are not parallel. So I hope I just added this for you. You're the first group actually, but this is kind of what I would suggest you do. So sometimes it's very obvious. One case, one statement, and you're good. So watch this. In each diagram, prove or show whether or not EF is parallel to GH. Is there more than one way to justify? And the answer is always yes. By the way, that's a rhetorical question. So here we go. My step number one, I'm just going to do it now. Step one. I notice that 67 degrees, right? I will do this. Angles are corresponding. You have a name, right? You have a name. Because not all angles have a name, guys. Not all angles are related by a name. Okay? But I noticed that the 67, right off the bat, you're like, hey, 67 here. I have a name for those two, actually. That's corresponding, right? So there we go. I know that they're corresponding. So I'll just kind of put like an arrow like that. Corresponding angles, right? Perfect. So that's step number one. You had to do no work to get that. Angles were already provided, right? So step two, corresponding angles are congruent. You know, right? We can tell for a fact now, hey, like corresponding angles, I have a name for them because they're not always congruent, right? But I have a name for them, and this is true, right? So property is true in this case, because it could have been 67 and 66. Property is not true. It's supposed to be congruent, but it's not true. Step three, you make a conclusion. Corresponding angles are in fact congruent. Therefore, EF is parallel to GH. The symbol for not being parallel, guys, is just crossing that off like this. Or you can actually just write not parallel. It's up to you how you want to do it. So there's a very high chance that you're going to skip step one in the future and just jump straight to this. You can jump straight to step three. It's like, hey, corresponding angles are congruent, therefore lines are parallel. Is there a different way to show that? What about these two? Do I have a name for these two? They're alternate something. Alternate exterior, right? They're also congruent. So perfect, right? I'll just say over here, method 2, and I'm going to do this faster, right? Alternate exterior angles are congruent. Therefore, EF is parallel to GH. Done. That is as simple as you can do it, but not always. Sometimes you have to do a little bit of work. Okay. This is method 2, a lot shorter, as you can tell. Okay, this is what I want you to do. I want you to do that question I told you about already, right? Page 2 or 3 was further 4. Sorry, this is the one I want you to try. I probably won't post the key. I will go over it with you tomorrow, but please try it. It's very beneficial. And I also want you to try pages 7 and 8, whatever remains of it. It's 3 questions, guys. So basically your homework is 7, 8 plus page 4. It's going to take you, I don't know, really maybe 15, 20 minutes, maybe less. Okay.